The topic of this presentation is geospatial systems in ports, and in particular, this will be a discussion about data, spatial and non-spatial data that make up these systems, and topics such as how to collect and evaluate the data that you have, assess which data you need to collect, how to migrate it to the format that you need it, how to use it, and how to keep it maintained. Hello. My name is Daniel Elroi, and I am the President and CEO of North-South GIS in Los Angeles. We are a geospatial systems integrator in ports, and over the past 5 years have built enterprise-wide GIS systems for the ports of Los Angeles, Oakland, Stockton, and most recently Tacoma. We're also engaged in other geospatial activities in ports such as Long Beach and Tampa. From our experience, we know that more and more ports are interested in having access to their data in ways like this, directly in the car, on a tablet, on a phone, right there in the field where it matters most, or in the office where it is used to communicate between different department members and with outside stakeholders. However, we are aware that many ports only have their information that they need access to in ways that are difficult to access, anywhere from DVDs that contain CAD drawings in the back of reports that were submitted by consultants, to file cabinets, sometimes just rolled up maps. And very often, comparing data that is contained in these maps or information related to them literally requires laying out maps, paper maps, on a desk and trying to make sense of it all. Finding information in this way is very difficult. We know that ports want to have information at their fingertips so that when any of these things happen, medical emergencies, the collapse of a crane, the bursting of a water main, the derailment of a train carrying hazardous materials, or even the collision between a vessel and a dock happen, they have information at their fingertips. With information readily available from different sources and available where and when it is needed, after hours, in the middle of the night, in a truck, or in hand, port personnel can do things like inventory the damage to equipment, access drawings or permit information directly in the field, issue work orders, stand up an emergency operations center, and ultimately fix the problem quickly and efficiently. Instead, ports often feel that they have to deal with situations like this, without access to authoritative data, without knowing where their information is at all, hampered by either personnel not being available when they're most needed, or information walking out of the door when experienced personnel retire. This isn't just a problem during emergencies, but also is an inefficient way to issue work orders for engineering work, environmental work, where contractors or staff do not have access to the latest information and therefore either make mistakes or have accidents or resurvey the field conditions before they start anything and resurvey them again and again. So, how do ports get there? How do they get to that place where they can have access to information where and when it's needed? They know the quality and the age of the information, they know where it came from, and they know how to use it in the most appropriate way. Geospatial data, after all, is everywhere in ports. It is in security information, whether it is in the form of perimeters, evacuation routes, do not enter zones, whether it is environmental, groundwater monitoring locations, contamination plumes, remediation sites. It is in planning, it is in bathymetry in the form of hydrographic surveys, contours, soundings. It is in the area of asset management, and ERP, enterprise resource planning. Where are our assets? Where are critical assets? How much are they worth? Those are spatial information that belong to geospatial systems. Of course, properties, leases, the management of properties and leases. What do we own? How much do we owe on it? What are we leasing? How much are we getting for it? And information that's related to the community. We're going to expand over here. We are cleaning up the environment over here. This will be the impact of our development. There's a lot of geospatial information at ports. Where do we begin? Where do we begin is a good question, and there are many ways to look at the problem and many ways to solve it. One way is to look at the process. This is the process view of solving the problem. We as consultants are very familiar with this process. We come in, point number one, we determine the needs and we help the port prioritize those needs. Why do you need to collect this information? Is it really important? How accurate does this information need to be in order to solve a problem? Then we go on to assess the conditions and create the plan. Do you have information and it's just hard to collect or access? Or do you not have the information and we have to gather it in the field? And how do we go about doing this? Do we do it over a 3-year period, a 5-year period? How will we pay for it? Will we have to hire anybody? So we help do that, determine that. Number 3 is we build the database, maybe by converting data from CAD, maybe capturing it from other paper documents, and then maybe we enhance the data with more information from the field. Data for data's sake is really not what it's about. It's all about using the data, and that is done through software. So we implement software systems that are either run on people's PCs or tablets or on phones and web browsers, either inside or outside the port. And then very importantly, we train people in the use of the data and promote the adoption of the system and the reliance on that data and the trust in that data. And this is a cyclical process. There is a different view of implementing geospatial systems at ports, and that is the software view. What database will I need to build? What software? What hardware? What network permissions, network security, cyber security? And then what software will I need to deploy? And how will users interact with that software? Does everything need to be really, really simple and only require 1 or 2 clicks to get information? Or do different people at the port have different needs and different capabilities? That is the software view. We believe that technological solutions, such as geospatial systems in ports, are really only about people. A system without training, a system without adoption by people, without the trust of people, is, just a paperweight, a digital paperweight. So the people view has to do with needs assessment and prioritization of people's needs and responding to those needs. It is about training. It is about user manuals, cheat sheets, things that make it easy for people to remember how to use the system. Finding ways to make sure that the system is used often, not just during emergencies. Doing outreach, speaking about the system, going to staff meetings and making sure people are aware that there are now tools that they may not be used to that can solve problems. It's even about trivial things that seem like marketing, but they're not. There are ways to get people to be aware, such as handing out cups or bottles or other little gifts within the organization to reward people for using the new system. So it's really about the people. However, today I am going to focus on the data view. That is the most elementary part of the geospatial system. How do we find the data? How do we assess its quality? How do we know where in the port it belongs to? How do we index that? How do we convert it into a format that is usable by all? And how do we integrate spatial data with non-spatial data? How do we publish it to our users, our staff? our contractors, our tenants? And how do we use it to make decisions, to make reports? And then how do we keep it maintained so that people trust it and it stays fresh? And then at times of need, how do we disseminate it outside the organization? The first step is to assess what data exists or doesn't exist at the port. In reality, a lot of the data that the port needs on a daily basis is in the port's possession, just not in the right format or the most accessible way, or in a format that can be compared to other data. So we start by doing an inventory of data, whether it is in paper or scans of documents or PDF files, or sometimes it is in CAD files or even GIS data, but it's on a DVD in the back of a report or somewhere that's not accessible. We work with port staff. Sometimes we bring in our own engineering experts or data experts, depending on the nature of the data, and we attempt to assess the quality and the most current, the most complete data for any particular data theme. We typically perform a needs assessment with the port to see which data is actually most important to the port and for what purpose. When a lot of the data is already in digital format, we can actually run some software tools that try and pick up a lot of that information about the data automatically, as you can see here in the left screen, and then we can catalog it that way. Ultimately, we will find data that is not available at the port, may require some inventory, may require surveying. It may be available in the local city or the county's GIS, or sometimes it's a matter of going back to an engineering company and saying, okay, what would it take for you to deliver that information that you delivered just as drawings in digital format? So there are many steps to the inventory and the assessment, and at the end of the day, we want to also help the port prioritize what to start converting to digital format first. An advanced form of assessment, inventory and assessment of the data, is to take the data that exists, whether it's in paper or CAD drawing format or what have you, and plot it out on top of the port's aerial photo or some other base map to show the extent of each one of these disparate data sets. So as you can see in this map, the green rectangles or the green shapes are the outlines of specific drawings or data sets. Not only does this help assess overlaps and therefore sort of prompts the port to determine which is the most current drawing for a particular area or for a particular theme, because different drawings or different GIS data sets might be for the same area but for different themes, engineering, environmental, electrical, and so on. It also helps assess the gaps in data. So if we look at the example here, the forested area at the top of the map doesn't appear to have any prior data for it, and so if the port wants to expand to that area, then that's an indication of a need for new data to be collected. Now, we do this in a way that actually can be delivered to the port and be used as a indexing system, a spatial indexing system, so that you can actually query the map and say, well, what data do I have here? And when you click in an area, you'll see on the left, for example, a list of all the documents with a description about which project the data was collected for, and if it's a drawing set, then maybe it will list the sheet number or the sheet description, the company that produced it, the date, and so on. And you then can actually open the document either as a scan or a PDF or a TIFF file, or perhaps open it directly in a software that can handle that data. In other words, you don't have to convert the data into GIS format before GIS can help manage and bring out more value from the information. In a sense, it's a geospatial document management system. And speaking of which, if the port already has a document management system and stores documents in there, whether it is a document management specific system like Hummingbird or just SharePoint or something like that, The links can be retrofitted, in a sense, to point from the GIS to that other system, so that documents don't have to be stored twice, once in the GIS system and once in the other system. So again, this is a great way to catalog what you have spatially and then decide what of it you want to go to the next step and begin the conversion to GIS. The key to building a geo database, as we call it, is really to prioritize what information is most important and in which format. So if the port starts off with a lot of scanned documents or even paper documents that can be scanned, it doesn't always make sense to convert every line work to intelligent data in a GIS. So if we look at the example in the upper left, one option is to scan the map or the drawing and georeference it and make it transparent so that you can actually overlay it on the port's own base map. And by own, we mean it can be an aerial photo either that the port has obtained or obtained from an aerial photography company or from the county that it is in, or it might be generic Esri aerial photography or Microsoft aerial photography. At any rate, georeferencing the drawing to it so that you can see it in context and in the right place, but it's just a scan. You can't click on things and get information from them. If you then go from the top drawing from here and go over to the next step, you can decide on which line work to actually convert. And the same holds if you already have CAD drawings that you want to make intelligent by putting them into GIS. It's not just for scanned maps. You can decide that you only want to, for example, convert the main lines, the main water lines in this case, but you're not going to bother with the laterals that connect to the service connections or to the meters because there's not that much value in them, or they might not be as reliable a piece of information. Now, once you convert the information you're most interested in, or you've prioritized as worth spending the money on initially, now it becomes part of the geodatabase, can be overlaid on the aerial photography, can be overlaid on property information, and so on. Of course, the value of digital map data when it's moved from CAD to GIS is that the information about things, whether they be fire hydrants as we see here, or fire lines, water lines, and so on, that information is converted from just text as it appears in the CAD version, like here, into database information. So you can actually click and find out the diameter or the material or the owner of that particular feature, as we call it. Now, of course, that also allows us to perform queries. For example, saying, show me all the 10-inch PVC fire suppression lines that we have at the port because we would like to start replacing those with something else, 12-inch or 18-inch pipes or whatever. So you can actually perform database type queries on the information once it's been converted. But going back to the original idea expressed over here, you don't have to convert everything. You can keep the scanned documents that have been georeferenced as a base map, a background, and then choose to convert that to digital format at a later date, if ever. Once the high priority data has been converted to a geodatabase, and any missing information has been collected, for example, the best way to continue the program and breathe life into the system is to make sure people get use out of it right away. If staff and contractors, tenants see value in the data and they can use it, then they will contribute more of their information to the system. They will fund the collection or the maintenance of the data and so forth. So we always focus on giving quick results for end users by means of creating, for example, easy to use web interfaces that do not require a lot of training. Here's an example of a port. We see the cranes, we see the storm drain systems and the outfalls, we see the water mains, we see the valves. And we give tools, for example, for users to be able to perform inspections like storm drain inspections for compliance purposes. Putting data into a geospatial system is really all about combining data, right? So here we have an aerial photo that may come from the local county. We have storm drain and water data that may come from engineering originally, but is now being maintained by the maintenance department. We have cranes, that's part of operations. We have ships, perhaps we bring in AIS vessel feeds, that is part of the harbor master's information that they might be interested in. Over on this picture we have properties, and we bring those in together with bathymetry. Over here we show an example of how we take building information or berth outline information, and of course the photos, and then link it to outside systems such as Bing aerial view or bird's eye view, the 3D sort of perspective view of the port. So we can link from here, from the port's own data, to outside systems. And ultimately it's all about generating reports such as expiring lease reports or contaminant and leasable properties reports, being able to make decisions, actionable intelligence, actionable information in the geospatial system in order to make decisions by the port, by its external stakeholders, and by management. One of the things that we are asked most often about the work that we do is what is the value of software, hardware, or even a large data migration, data conversion project if the port doesn't have the staff, the know-how, the resources, or the processes to keep it maintained. We think that that's a critical part of creating a good system, a sustainability plan for it. So for example, one of the things that we do is put in the hands of all users, with the agreement of the port, of course, a tool, a web-based tool that can be used in a handheld or in the office to redline or mark any problems with the data, to mark points that need to be added because they're missing or modified, maybe they need to be moved, or maybe their description needs to be changed or removed. And the same goes for lines and polygons or areas. In this way, end users, the staff, can express their experience with the data and inform people who actually are in a position to update the data of their observations. We actually allow end users to upload supporting information such as a photo to prove their point that something isn't there anymore even though it's still on the map, or a design document and so on. In this way we try and encourage end users to trust the data rather than finding a mistake and deciding that the whole data set or the whole system is untrustworthy. Instead, we try and get them engaged and involved in that. Another very important aspect to updating the data, especially in ports, is to integrate GIS with CAD. Some ports have their own CAD operations, but more often than not, it is third parties such as engineering firms that do most of the CAD design work for a port. So we have developed processes such as the one shown in this diagram that explain to the port, and we often teach this to port and contractor staff, how to take authoritative data that has been QA'd at the port, export it to a CAD drawing, a compatible drawing, and then showing the contractors or the end users of the CAD system what they need to do to the data so that it becomes GIS compatible. In fact, what this form here shows is a quality assurance tool that can be performed against those CAD drawings to ensure that that data can be then integrated back into the GIS. And in this way, every project that the port lets out can not only start from reliable and authoritative data, but can contribute to the quality and the longevity of that data. Another aspect of building trust and building momentum in this geospatial system, which, as I said, does not just consist of GIS or CAD, but can consist of GPS, AIS, and other geospatial systems, is to put the data in the hands of whether it is maintenance staff in the field or tenants or contractors, allowing them to access this information in the field, but also update it with service requests or work order requests directly from the field. Another important aspect is to talk about it, talk about the system, participate in regional lectures or conversations, conferences, bring in and educate other stakeholders, whether they be engineering contractors or public safety agencies or the neighboring city or county, so that the awareness of the data that is at the port or outside the port is increased, and the ability to collaborate and share, whether it is during normal operations or during emergencies, is increased in that way. So this is a cyclical process of update, dissemination, and then re-examination of what additional data is needed, where the new gaps are, what the new uses are, and so on. I hope that this presentation has grabbed your attention and has started you thinking about the next questions. Questions such as, what is the actual return on investment in a system like this? Do the facts support intuition? My intuition tells me that this is a good idea to have information at my fingertips. But what is the value proposition? Will I really save money? Will I be able to lease properties faster? Will I be able to reduce my liabilities by ensuring that contractors and staff have access to the latest information? That would be one set of questions. Another one is, how can this be financed? Granted, a lot of this information is already in the possession of the port, but building the systems, converting data, making sure that that data can be linked back to the original systems, all these things require money. So even if we have a return on investment story here, how can we finance it? Should it be from grants? Should it be from capital expenditures? Or can it be a combination of capital and operating expenditures? Will we have to hire people, for example? And do we have to let this out to bid for, what's the best way of doing this? Another set of questions has to do with resources and management. Do we need to hire staff? Do we have the staff? Can we train people? Are the people that we have, can they be retrained? Can we collaborate with a local city, county, university, or what have you? And how should this system be managed? Because an enterprise system like this really requires collaboration between different departments that don't always work together or don't need to. What about governance? How high an organization should the system be sponsored by? The CEO, the executive director, or the director of operations? Is this an IT system? Is this an engineering system? Is it both? Another question is, what is the best way to phase this? Obviously, this is something that doesn't happen overnight. What is the best way to ensure staff adoption? We do not happen to believe that just if you build it, people will start using it. On the contrary, people need to be assured that the data is good, that the results are good, that they're not going to replace the need for personnel, that on the contrary, this is a way to ensure that the knowledge that retiring personnel, for example, take with them, or people who leave the port, is still available to others. Training, computer usage, these are all areas that need to be dealt with. And as I mentioned in the previous slide, how can data quality be ensured and sustained, which I already covered, but these actually have practical questions. How do we make sure that contractors actually follow these processes? And if they tell us, the ports, that this will cost more money to do this, is that okay? Is it important enough for an engineering project, for example, to actually have a data component and to pay for that data component so that we know with confidence what in fact was built and when, is a justifiable cost? Well, there are many questions, and we feel that we have been able to help ports answer those to their satisfaction and to the point of action. I encourage you to look at our website, especially the URL that you see here, ports.northsouthgis.com, to get more information about what other ports have done, what they're doing today, how different ports are similar, and how they're different. What solutions are right for medium to large and super large megaports, and what solutions are right for small to medium-sized ports. For example, some solutions are available on site, installed at the port. Some are available in the cloud. How do we feel about the cloud? How do we feel about cybersecurity? These are all questions that we would love to discuss with you. I encourage you to email us or to call me personally at the number you see here on the screen. Thank you for taking the time to listen, and I hope that we get to speak again soon.